the last topic that we do in this unit is higher order derivatives. And it's not hard. So, I don't know if that's a disappointment right off the bat. This is easy. All a higher order derivative, like these are second derivatives. The notation for the second derivative, well, if the first derivative had one little dash, the second derivative has two little dashes. Leibniz notation got a little crazy. They put some squares in there, but they square in between and after. The reason for that is because technically, this is how you find the derivative of something, d dx of y. And when you do d dx of y, they kind of think of it like, oh, if I made that a fraction, I write my regular derivative as dy dx, but it's really d dx of y. And if you did it twice, you would have the d squared, the y is still only once, and you'd have the bottom squared, but mathematicians don't actually like to write the extra brackets around the bottom, so they just put this, it's like cheaping out a little bit on notation, cheating a couple ways, but that's sort of where it comes from, and why the squared is in between, and the other one is after. Technically, there probably should be brackets there to say the whole dx on the bottom got squared. But we won't worry about little details of notation. That's Leibniz notation. And how do you find the second derivative? You find the first derivative, then you find the derivative of the first derivative. That'd be the second derivative. And the third derivative would be finding the derivative again. And so if you know how to find derivatives, you now know how to find second derivatives, third derivatives, 1500ths derivatives. They just take longer. So, if f of x is this, probably the first thing you would do in this one is say, I would like to change this to look like a form that's easier. Or if you just love the quotient rule, I guess you could do the quotient rule on the second part. But I would probably recommend changing it to an x to the minus 1. Then, your first derivative, well, that'll be 3x squared, and this will be plus 5x to the minus 2. And if you found your first derivative, you could just take the derivative again to find your second derivative. That first term will now be 6x. The negative 2 would come out in front, subtract 1 from the exponent, and we would get negative 10x cubed. Very nice. Do you see a chain rule? Okay. So sometimes you would, if you're doing a second derivative, sometimes you have to make the decision. Might you want to multiply that out, cube it? Like, oh, cubing, that's a little bit of work. Maybe I'll just do the chain. So if I did the chain rule, then you see that the first derivative would be my outside function is the cube. So do the derivative of the outside function, subtract 1 from the exponent, keep the inside function the same, then multiply by the derivative of the inside function, which will be 2x minus 3. Okay. Now, to find my second derivative, I have a product rule and a chain rule. But you guys were getting pretty good at these on the board the other day. So there's my notation. Product rule says keep one the same. So I'm going to keep the first one the same. And multiply by the derivative of the second one, just 2, plus, then keep the second one the same, and multiply by the derivative of the first one, And the first one is a chain rule because I have something inside of something. So the 2 would come out in front, keep the inside the same, subtract 1 from the exponent, then multiply by the derivative of the inside. Now if I asked you for the third derivative, I'm not going to, but can you see that you would have a chain rule at the beginning, not too bad, but then a double product rule in the second one, which could get a little bit messy. So it might have actually made sense to multiply this out. How good are you at these ones? Remember Pascal's triangle binomial theorem expansion? So if I had simplified this out, I would get x to the 6th minus 9x to the 5th plus 27x to the 4 minus 27x cubed. The nice thing about multiplying it out is now first derivative, second derivative, third derivative, fourth derivative. I hope you can see that they're all going to be straightforward, no product rules, no chain rules. So, whereas in the first derivative, I would say no. Never should you multiply that one out, because the chain rule is not that hard. It's pretty easy to get the answer. And you don't have to simplify, so that's fine. But now, our first derivative was fine. Our second derivative wasn't too bad, but if I had to find the third derivative, it would not be very nice. In this one, I can see that by the time I get to the 7th derivative, my answer is going to be just a number. Might be, and then the 8th, once it becomes just a, like, the first derivative would give me a 6x to the 5. The second derivative would give me a 30x to the 4. Then I would have 120x cubed, 360x squared, 720x, then just 720, and then 0. For that. And the other ones would go to 0 faster. So it's kind of interesting that way to simplify. But not necessary. You have that choice. No need to simplify. So that one would be 4x cubed. Can you see that the negative sign 2x would be a chain rule, that the 2x is inside of sign? So its derivative, the derivative of sign is just cos, keep the inside the same, multiply by the derivative of the inside. Then my second derivative, 12x squared, we have another chain rule. Right? I can think of that 2 in my head. I already moved that 2 out to the front of the equation. It's negative 2 cos 2x. The derivative of cos is negative sine, so this will become plus 2 sine, keep the inside the same, multiply by the derivative of the inside. All right. I will let you try B, C, and D. I will put up the answers in a bit. Our second derivative. So the first derivative is a chain rule, and then I wrote it as a fraction. And then for the second derivative, I had to use My quotient rule. Everybody good? Almost? Yes? No? Okay, let's look at the next one. There is a product rule here when finding your first derivative. And in that product rule, the second one has a chain rule because the negative 2x is inside e to the x. So we keep one the same, derivative of the second, then keep the second the same. Now I took that, I wouldn't have to do this, but I noticed that there was an e to the minus 2x in both of them, and I factored it out. So that when I did my second derivative, you could do your second derivative with what's here. If you factor it out, then you only have a little bit less when you do the second derivative. So if you didn't factor it out, your second derivative would be the same but look a little different. You'd have 3 terms instead of 2. And ready, check D. First derivative, chain rule in there. I moved that 5 to the front to make it 10. Second derivative, chain rule again, negative 50. Can you see that there was a 2 up in front? Then there's a 10. And then there's a 50. What would the coefficient be of the next one? Negative 250. And I don't know if you noticed that the numbers in front go 2, 10, 50, 250. What's happening? We're multiplying by 5. So this would be a great way to bring in geometric sequences unit combined with derivatives unit. And you will see that on the exam. They're like, ooh, if we keep doing the derivative, we can make a geometric sequence. So then the question becomes part A, find the first derivative, second derivative, third derivative. And then part B says, find the coefficient of the 42nd derivative. P.S. Don't find all 42 of them, that would take too long. And then you have to find out the geometric sequence part and find out how the positives and negatives are changing and figure that out that way. Because that's one of the favorite things that IB likes to do is connect units that don't seem connected together. All right, try example 4. In example 5, I will put up the answers in a bit. All right, so there's the first derivative. There's the second derivative. I'll put it on the video. Perfect, there it is. The f double prime of 1 means you have to find f double prime of x, and once you've found it, then you plug 1 in for x. So I found f double prime of x to be 16e to the 2x, then f double prime of 1 will be 16e squared.